Okay, everyone. So we are discussing the next network interconnecting device, and that is the bridge. Now, to understand this network interconnecting device, first of all, I am taking one example. Now, let us suppose that we are having three switches. Let us suppose this one is switch number one. Then afterward, we are having one more switch, and that is switch two. And then we are having one more switch, that is the switch 3. We can also take the example of the hub if we want. Both will work fine in that case, but we are assuming that switch is there because that is more popular, and I'm assuming the switch with the 4 ports only. I'm taking the small diagram, so every switch is having the 4 ports. 4 ports means 4 computer can be connected with that. Now 4 Ethernet cables are connected with that. So these are the Ethernet cables which are connected. Now C1 is the computer, then C2, C3, C4. So 4 computers are connected with the switch 1. Then I'm taking another number C5, C6, C7 and C8. Then further C9. I'm taking all the numbers different so that we can easily observe what is going inside that. C12. So these are the three switches with the 4 ports. Every switch is creating the LAN. If the switches are independent, they are not interconnected. So they are the different LANs. So this is the LAN 1. And the next one we are having is the LAN 2. So this area is the LAN 2. And then further, this area we are having is the LAN 3. These are the separate local area networks. Now, we know that human are very unsatisfied person. Human have created multiple switches, and we know that with the help of switches we can couple them. Now, let us assume that the coupling happen. So the switch 1 is coupled with the switch 2. Switch 2 is coupled with the switch 3. Now they all are creating one network, so we can say that this is whole is a one LAN, or we can say that if there are multiple switches connected, it can be a MAN also, metropolitan area network. No problem. The problem happen, you see, if C1, this computer, this particular computer want to send the data to C11. Now what is happening? First of all, it will go to the switch. Now, switch will find whether the C11 is there in its own network. Switch will say there is no as such C11. So it will route to outside. Now it will send the data to the next switch. It will find, is it available there? No. So it will just forward it to the next switch, and it will find that C11 is present and data is sent to the C11. Although connection is virtual, we are having no problem. But let us suppose one more case. Now if C10 want to send the data to C3, in that case what will happen? It will send the signal to its own switch, its own, then afterward checking all other computer, not finding, then again going outside, sending through the coupled wire. Now checking inside the switch 2, not find, Again going to switch 1, then it will find and send to the C3. So the data is going to C3. There is no problem in this particular conversation because we know that there is a virtual connection, but we should see one thing. The switch 2 is unnecessarily seen. Means everything the switch 2 is communicated. You can see that while we are conversing from C1 to C11, switch 1 2 is coming into picture. We are sending from C10 to C3. Again switch 2 coming into picture. There will be too much load on the intermediator. Intermediator means switch 2 because the switch 2 is coming in between. Every time somebody want to communicate, the switch 2 will be coming in between that, and that will increase unnecessary load. So there is an unnecessary load on the switch 2. Now we are learning the topic bridge. That means we are thinking like there should be some kind of overbridge. Overbridge means there should be something that we are connecting from here and it is directly going to the switch 3. So there should be overbridge. Overbridge, we know that if we don't want to go at some place, then we should be having some overbridge. So that bridge we are talking about, so there is a device with the help of that we can cross something. And yes, we can also connect that particular switch also. So if some overbridge is there, this is called the bridge. Now if I am going to modify it, then I will modify with the help of one device. So now this one is the overbridge. With the help of that, we can send the data directly from switch 1 to switch 3. But yes, if switch 1 want to send the data to switch 2, then obviously this overbridge is having the connection with the switch 2 also. So that now we are having the freedom. If somebody want to communicate, we don't have to go to that person. We can go directly. But we know that there is no such bridge happen. There should be some device in the network. So we are replacing this with the help of one device. So now let us suppose that we are having this device. Now this device is there and this device is having the different ports available. Let us suppose that 3 ports are there, 1, 2 and 3. Now this device is the bridge. So there is one more device which we are learning is the bridge, and bridge is having the multiple ports, and that bridge is the network interconnecting device, especially it is the LAN device. So now the wires are connected with this bridge. Now if I go with the same example, let us suppose that C1 again want to communicate with C11. Now what will be going in that case? It will go to his switch, checking its own ports, not find. It will go above. Now from here, it will send the data to the bridge. Now bridge is very intelligent. Bridge is having one special feature that is called store and forward feature. So bridge is having the store and forward feature. Means it is used to store something. And what is something? The data which is sent by some system. So the data which is sent by the C1, this data is now gone to the bridge, and afterward it is going to store here. It will store it here. Then it will search where to send it. It will see that the switch number 11 is into this particular port. So this data is now sent to this one. So this one is not interrupted. Switch 2 is not aware now. It is not involved at this time. The data is directly sent to the switch 3, and with the help of switch 3 it will find that C11 is there. and data is now forwarded to C11 directly. So that is the bridge. Bridge is the device that is used to store and forward. Store and forward means it is storing the data, then forwarding it. There is nothing like that bridge is going to take out some different activity. No, only storing and forwarding and only sending to the appropriate network. And one more thing we should know, that bridge is the LAN device. LAN device means it is going to work with the LAN. Now we guys have many idea about the network, and we know that we are having the PAN. PAN is the personal network. When we are connecting two or three people with the help of Bluetooth, just like we are having the headphones, we are having other wireless devices or one-to-one communication, NFC, these are the personal area network. Means we are connected to a shortest distance, just like we are connecting our phone in the car, right? That is a PAN, personal network. Then further, if we are having some bigger network, that is LAN, so up to 10 kilometer we are connecting with the help of wired or wireless connection, then that is a LAN, local network. Local network is having very high speed. Why? Because the network size is small. And the devices in the LAN, we should know all the devices which we are learning, just like the hub, the switch, bridge, gateway. So these are the devices which are the LAN devices. Now if I increase the size of the LAN from 10 kilometer to more, just like that is called the metropolitan area network, we say it is MAN. Now LAN and MAN both are the same thing, means all the topologies are same, all the devices are same. But if somebody asks you what are the LAN devices, your answer will be hub, switch and bridge. If somebody asks you what is MAN device, same answer, hub, switch and bridge. Although there are few more devices which we will learn, like repeater is there, gateway is there, we will learn them also. But both are having the same kind of device because their topology is different. Only difference is their distance, how much distance they cover. LAN cover approx up to 10 kilometer, MAN cover up to complete city. If let us suppose that you are connecting 2-3 buildings, that is the example of LAN. If you are connecting whole city, that is a MAN, but devices are same. But if you want to connect city to city communication, country to country, continent to continent, then there is a bigger network, that is the wide area network. And in the WAN we are having device, that is the router. So router is very famous device. That is only the WAN device. Otherwise almost all the devices are LAN and the MAN devices. Easy to learn. So there we have learned that bridge is the LAN or the MAN device. So there we have learned about the bridge, and bridge is the LAN and the MAN device, and it is used to connect the multiple LANs. Now we can see that if we are connecting multiple LANs, that is becoming a MAN. So that means all these LANs are connected with each other, and these multiple LANs are combined, and if the range is crossing the 10 kilometer, so they will become the MAN. So all these now are connected, and this will become the metropolitan area network. It is not necessary that this diagram is only supporting the MAN. If you are putting the bridge into a small room and few switches are there, that will be the example of LAN. Why? Because you are not crossing the limit of 10 kilometer. But if you are taking many switches in one city and they are connected to the bridge, then you can take the example of the MAN. So this diagram can be taken as the example of metropolitan area network. And now we are going to learn the next network interconnecting device, which is the WAN device, router. So now we are learning the next network interconnecting device, and that is the router.